Alright class, let's do the next video. This is just a review. Again, the same standard. For those that are curious, look it up. It's in the Florida website. Here, these are the things we went over before. Again, with two parallel lines, you have this, all this following is true. Corresponding angles are congruent. Alternate interior, exterior congruent. Same side. Interior and exterior supplementary. And these are just the actual postulate and theorems that relate to this. So if you don't have these for your notes already, pause the video and copy this and make sure you have it in your notebook. Now, this is what we was doing in class, which is the Converse. Converse, like the Converse sneakers. The easiest way to remember the Converse sneakers actually has their logo on the opposite, where you usually would have it. If you want in class, I'll explain it, but usually the logo sneakers are on the outside of the shoe, so people can see it as you walk around, but for whatever reason, Converse has it on the inside. And all Converse means is that you're just switching the original statement. So in other words, if P, then Q. P is really the given, and Q is what we call what you're trying to prove, or in this case, the hypothesis and conclusion. And all you're doing with the Converse is switching it. All theorems are the same. If it's a theorem, you can prove it backwards or forwards. So, for example, the alternate interior angle theorem states that if two parallel lines are intersected by a transversal, then the alternate interior angles are congruent. So the reverse should be true. You can write the converse will be basically if the alternate interior angles are congruent, then let me just put this over here. Then the two lines oh yeah, let's just keep it simple. Then two parallel lines are intersected by a transversal. And now it'll just be the converse. You're just switching the statement itself. The conclusion becomes the hypothesis, and the hypothesis becomes the conclusion. So in other words, here the hypothesis is always after the word if. So here the hypothesis originally was just two parallel lines are intersected by a transversal. That's it. And the actual conclusion comes after the word then. And this is how we actually use the proof too. The alternate interior angles are congruent. And that's it. So that's how you do the rest of them. I only did the first one for you. But that's basically what the converse is. The converse is just the reverse or the opposite. And it makes sense. If when the lines are parallel, the alternate interior angles are congruent, so the reverse should be true. If you find out the alternate interior angles are congruent between the two lines that are intersected by the transversal, then those lines must be parallel. And that's how the converse works. The next slide. So here, we didn't do this in class because we don't have a compass, but I'll do it for you here so you can see how it works. And if you guys like this, I'll do a poll later and see if you guys are interested in doing any kind of construction. If we got time, we'll do it in class. I think it's fun, but that's just me. So who knows if you guys also think that as well. So here they want us to use the corresponding angle converse postulate to construct a line parallel to line R. So all we got to do is just take this angle and copy it up here with the compass. And then once we copy it, then automatically based on the converse postulate of corresponding angles, then this line here will be parallel with this one. So I'll show you how that works. So first thing, you just take your compass and you just put it here. Now obviously I want a smaller angle, so I'll put it like that. Alright, and you just draw an arc, which is just basically part of a circle, like so. Alright, and the next step is to place a point on the transversal, which is S. So let's place a point there, somewhere up here. That looks good. All right, and now we're going to basically make the same arc that we made here. We're going to make it up there, so that way we can actually copy the segment. Not the segment, but the angle, sorry. You got to have the same arc, because that way everything comes out equal. And all the arc is basically the center. So I want this center to be the same thing as this one of the circle. And if I do that, then I know it's going to work. Oh, hold on. I don't want that. There we go. Okay, that should work. All right. So now I know this circle is the same as this one. So then I can copy this distance of the circle here and now give me my angle. And that's easy. All you do is you put the point here where the circle touches line R, or you can do it from here. It doesn't matter. As long as you just copy the distance. And it's easy to copy the distance with a compass because you're not measuring. You're just putting the center of the compass on one point, and then you just measure with the pencil. So let me rotate it right here. I'm actually pretty good. Let me see. Let me make sure. Yeah, it's pretty good. That's actually nice. So just mark it. Make sure you're good, and then you just take it, put it here, right where this circle touches line S. That's about right. All right, good. So then we just mark it, and there we go. So now I know when I draw it here, this is going to be in the same spot as this. So you just take your ruler and complete the angle, like so. Okay, let me see. Yeah, that's good. All right, right there. And then we just draw the line. Oh, hold on. There we go. Okay. I wasn't sure if I did it or not. All right, and that line is basically parallel with this one. It looks a little off, but on paper, it'll come out a lot better. And this line, we're going to call it S. Is it S or is it, what do they want us to call it? Not S, obviously. Oh, we'll just call it whatever we want. So I'll call it T. And again, if you like this, then we can actually do this in class. But this is basically why parallel lines are parallel based on just the corresponding angle. So now that we did that, all right, so line T is parallel with R. We're good to go. Only thing I'm missing here is the arrows. I'll try to do it, even though it's going to look ugly, but that's fine. There we go. Now it's a line. All right, so now line T is parallel with R. Why? How do I know that? Because the corresponding angles are congruent. And these actually look really good, so it's actually not as bad as I thought. And then here, what do you put for here? What's the transversal? Easy. You just put line S. And what lines are parallel? Lines T and R. There you go. So again, the converse works because that's how you draw parallel lines by hand with a compass. You have to make sure that the corresponding angles are congruent. If they're congruent, the lines will always be parallel. So that's why the converse works. And obviously, you know, if these lines are parallel to begin with, these angles will be congruent, which are the corresponding ones. Don't forget, corresponding means that they're basically in the same spot of each line. So just like this. All right, let's do some proofs. I'm only going to do 2. And then you can do the other one. So I'll do 1 and 3, and you will do 2 and 4 on your own. It's basically the same thing. Now here, how do I know how to put this? Let's look at the statement. Alternate interior angle converse conjecture states if 2 lines are intersected by a transversal, form congruent alternate interior angles. So that right there is my given. Let's use a highlighter real quick. So this is my given right here. Okay. And then So that's why I got there angle 3 congruent to 6. Those are what we call alternate interior. And we're good. Alright, and then it also says then is the conclusion, what we're trying to prove. And what are we trying to prove? That the lines are parallel. So here we go. Alright, so the way to prove this is the same way we did this construction here. If we can prove the corresponding angles are congruent, then the lines have to be parallel. So we're going to use the corresponding angle converse postulate to prove all these proofs. So at the end, I got to get a pair of corresponding angles to be congruent, so that way I can prove W and X are parallel to lines. Alright, so let's just get a pair of corresponding angles. In this case, I'll use 2. So I'll use this. So I'll use 2 and 6 to make it work for me. And I just noticed that if I use 2 and 6 to make it congruent, I already have here a pair of verticals that actually have a relationship with 2 and 6, and a relationship with 3 and 6. So let's just work with that. So to do that, I'll just use some flowchart proofs for this one this time. So I'll just make one here. Got my little box. Alright, so alright, and I'm good. Alright, so let's just start it. So here, the given is simple. It's this. Is angle 3 is congruent with 6. So you saw that's what you would put there. Hold on a second. Let me just work with this. Yeah, I need that. Alright, let me undo this. There we go. And I'll just put this here. Yeah, that wasn't very smart. I'll just write it out, because I don't want to waste time. Alright, angles 3 and 6 are, and then I'll just cheat with this, are congruent. A little congruent sign here. Okay, and that's basically given. Okay, and then from there, like I said, I noticed I had a pair of vertical angles, so I'll use those, which are 2 and 3. Put them here. Let's make this bigger. So angles 2 and 3 are also congruent, so angles 2 and 3 are, and we just take our little congruent sign. If I can do this by hand, it'll be a lot easier, but that's fine. It's not a big deal. All right, here, why they're equal? Because they're vertical angles. Again, once you remember all these different angles and terms, it just gets easier. So as long as you practice little by little, it'll get much better. All right, and then here, I'll just put it here, and then I can just tell by looking at this. Angle 6 and angle 2 are congruent to the same angle, which is angle 3. So in that case, I can deduce via the transitive property that angles 2 and 6 are also congruent. And why? Because of the transitive property. So I just put transitive. Alright, so that goes here. Let's move this here. I'm just trying this, but I think next time I do proofs, I'll stick to the 2 column, because it just looks neater. But for this video, I'll just keep it as is. There you go. All right, now that I have this, 2 and 6 are my corresponding angles. They're congruent, so per the converse theorem of corresponding angles, these lines are parallel. So then, let's get another box, put it here. This one I'm going to try to do right. So I'm just going to put W, and then put X, just stick them here. And then get my parallel symbol. Oh, where'd it go? Oh, okay. I guess it won't work. Hold on. Okay. Well, sorry about that. So we'll just write it by hand. So then lines W, W and X are parallel. And the reason for that is converse of corresponding angles. And that's it for that proof. So yeah, we don't need this box, and we're done. Now, the only thing you want to do, if you want to, just put the order there. So there you go. If you used to do this in 2 columns, this will be 1, 2, 3, and 4, and that's it. Only took 4 steps, and the only thing that really we needed here was just the vertical angles to tie in with the corresponding angles with the original alternate interior. So now, the same way I did this, try to do number 2, which is not alternate interior but alternate exterior. Okay, we got one more proof to do, and this is now same side interior. So again, the if gives you the given, and the given here was supplementary interior angles. Oh, I messed that up. So yeah, let me take this out. I'll just write that by hand. Yeah, that was a mistake. So we'll leave that. Where are we? Okay, good. And then here, I'll just put here, still by hand, angles 1 and 7 are supplementary. There we go. Alright, so now that I got that, now let's just prove it. So we're talking about this one. We're talking about this one and this one. So if those are supplementary. Oh, no, same side, 1 and 7. My mistake. Here we go. That makes more sense. All right. These are supplementary. What I just had was alternate exterior, which is congruent. So these are supplementary. These are kind of like linear pairs, except they're separated. But if I was to slide this here, is the same as 3, which is what we're going to use. Since if I know 7 and 3 are congruent, I'll use that to prove that 1 and 7 add up to 180, because obviously 1 and 3 add up to what? 180, because they're linear pair. So I'll use that relationship to prove that these lines are parallel, because I know 3 and 7 are congruent, which are corresponding angles. So let's just do the proof on the next slide. So I'll do it here. And I was going to do that, but I think it'd be easier if I just do it this way. Let me just get my 2 columns and call it a day. Yeah, that's good. So that'll work. There we go. All right, so all of this stuff here, let's just get rid of it. All right, and of course, for the 2 column, you have your statement and your reason. All right, so the first statement, number 1, angles, I believe was what? 1 and 7, yes. All right, angles 1 and 7 are supplementary. All right. And the reason for that is simple. It is given. All right, good. Now the next one, number 2, since they're supplementary, we know that the measure let me get this here. This I got to do it this way. So the measure of angle 1 plus the measure, need some space, of angle 7 is equal to 180. So we put that like that. Good. And then let me just get the angle symbol. Yeah, there we go. Not very pretty, but you get the gist of it. Okay. If I can only move that. All right, finally. There we go. All right. And the reason for that is definition of supplementary. All right, so let's use that linear pair that we talked about. Here, since I know 7 and 3 are going to be congruent because they're corresponding, I use the linear pair relationship 1 and 3 have to be able to prove that 7 and 3 are congruent. So here we're just going to write, for the second reason, angles 1 and 3 are linear pair. And that's good. And since they're linear pair, we knew, how do we know that? Because definition of linear pair. All right, moving on, since it's a linear pair, they have to be supplementary by definition again. Well, also some books skip this step and they just go straight to the measure 1 plus measure 7. In this case, it will be measure 3 plus measure 1 is equal to 180. So here I'll just put here step 4. How do we know that? Because definition of linear pair. I'm doing this kind of fast, so I'm not really worried about the capitals and all that stuff. So, all right, let's move on to 5. That's going to be, since they are supplementary, the measures got to add up to 180. So, measure angle 1 plus measure angle 3 is equal to 180 degrees. And don't forget, I'm missing the degree sign. So, then here, let me just get the angle symbol. And there we go. Looks a little better. Okay, good. And then what's the reason for this? Simple. Definition of supplementary. All right, now if you notice here, there's different ways to do this. I'll give the shortcut here in the video and then I'll take it out so you can see, but I can actually end this here because I already see that 3 and 7 are a supplement to the same angle, which is angle 1. And there's a theorem for that, which is basically saying If one angle supplement to the same angle as the other angle, then those angles have to be congruent to each other. So I can just simply put here angles 3 and 7 are congruent. And how can I put that? With the reason that angles supplement to the same angle are congruent. That's the reason. So that's one way of doing it. And then once you've done with that, you just put obviously 3 and 7 are corresponding and they're congruent based on this reason. So here you just put lines W and X are parallel. Well, actually, let me see. Let me just use this. That was a bad idea. Here we go, finally. Alright. So this is a shortcut. Now, I didn't show this in class because, you know, this was just something that I introduced and it was part of the theorems you did. But, you know, for the kids that remembered it, they could have just done this. Now, this is one way. Now, I'll show the other way in class. So if you want, just pause this video so you can copy this. So this is one way of doing it. And this also works too with the angles that are complement to the same angle. It's the same theory. If both angles add up to 90 with the same angle, then they both have to be congruent to each other as well. And here we just put again, why is this possible? Because of the converse of corresponding angles. Alright. Okay, so let me just take this out and let me just do it the way we did it in class. So the way it was done in class was a little different, but it doesn't matter. The way it was done in class was we just put the two pairs together. So measure of 1 plus the measure of 7 was equal to the measure of 1 plus the measure of 3. And we was able to do that via substitution. Yeah, so this reason changes. So let me take this out and just simply put substitution property. Now this to me is easier than the other one because this is a little bit more natural, in my opinion. If you remember the other one, that's fine. You can use that. So then this changes. This doesn't become, the 7 stays, but this actually goes down here. Because we got one more step to go. We got a couple actually. So let me change that 7. Let's just take it out for now. Because we don't know. That we can leave. So now that I see this, I already see angle 1 is on both sides, so I can eliminate angle 1 which by simply just subtracting. So I'm left with measure of angle 7 is equal to the measure of angle 3. And again, we did that by subtraction. Again, this one's a little bit easier to see because it's kind of like more algebraic, I guess, because you're using math to take out certain things, or arithmetic more specifically. Let me put the angles. There we go. And finally, since you know those angles are equal, then their measures have to be congruent, obviously. per the definition of congruence. There we go. And the reason for that is, as we said, definition of congruent. And once angles 7 and 3 were proven to be congruent, we knew those were corresponding angles. So based on the converse of corresponding angles, lines W and X must be parallel. So this proof is done. So the same way I did this, try to do number 4, which asks for not same side interior, it asks for exterior, I believe. I just noticed I did the exterior, so this is actually technically number 4, so try to do number 3, which is the interior. Sorry about that. But I hope this video helps. Thank you for watching, and see you in the next one.